folks, continuing along where we left off. So more stuff on complex ions. And now specifically, I want to get into these polydentate ligands. And those are, for those of you that are good with your Latin, you'll recognize this as many-toothed ligands. So what that means now is our Lewis bases here that make up our ligands, right, that donate electron pairs to a central metal, they have two spots in which they can do that. So I'm going to back up here just a moment and I'll remind you of all of these common ligands that we talked about. And I mentioned this number of donor groups, and you can see for the vast majority of them that we spoke about, it's one. But here's our ethylene diamine with two donor groups. So let's flush that out in more detail. So here is the ethylene diamine molecule. Again, it's ethylene. So ethyl means two carbons, and there they are. And diamine means two amines, and there they are. Okay, and you can see that each of these amine ligands has a lone pair to give. And so because there's two lone pairs in this one ligand, that makes it a bidentate ligand. So bi meaning two. So for example, here is a picture of ethylene diamine surrounding a metal. So as you can see on this metal here, it's also coordinated with water molecules, 1, 2, 3, 4 water molecules, which are all monodentate. And then here are these nitrogen groups represented in blue, acting as ligands to the central metal. Okay, and so now, as you can imagine, right, this has a coordination number of 6. So we could also completely surround that metal, or I'll use another word, which is sequester. So we could completely sequester that metal with 3 of those ethylene diamine molecules, because we recognize this particular metal has a coordination number of 6. You know, whatever this metal is, it doesn't matter for the point of this discussion. But now you can see this makes a really nice cage around the central metal. So we could expand this even further from bidentate into hexadentate, which the ligand EDTA, which is ethylene diamine tetraacetate, is a hexadentate ligand. So if we count them all up, you can see there's the 1, 2 nitrogen groups. And now each of these oxygens that has a negative charge, so if I were to blow up what this thing looks like, I realize it's small. So there's a carbon atom, and it's showing you here this resonance structure. But I'll draw it without the resonance structure. There's an oxygen double bond, and then there's an oxygen single bond that's negatively charged. And we can see now that we have 3, 4, 5, 6 of these things. So this makes EDTA a hexadentate ligand. And so because of this, EDTA is actually a common food preservative. And it acts as a food preservative via the chelation effect. So the chelation effect is this idea that if we have these polydentate ligands, they surround the metal, so they sequester the metal, and they render that metal inert from doing any other chemistry. So for example, as we'll see in the coming slides, some metals can act as acids. Some metals can also do redox chemistry. So for example, if you had some metal ions floating around in your mayonnaise, that can enhance the spoiling of that mayonnaise. Those free metals can either promote oxidation reduction chemistry or it can promote acid-base chemistry. In either scenario, those free metal ions are going to spoil the food. So this is one of these modern miracles, better living through chemistry. If we put a little bit of this food preservative, EDTA, it sequesters the metal, or in other words, it chelates the metal. I know I'm giving you like a whole bunch of different words that all mean the same thing. But this is in principle the chelate effect. When we have a polydentate ligand, it surrounds the metal, it sequesters it, and it renders that metal inert, which means it works as a really nice food preservative. And so I know, especially in Arcata, we're all about the natural food diets and all that stuff. So don't knock food preservatives. They're actually a good thing. We wouldn't be able to ship food across the world if we didn't have these common food preservatives. So the thing that we want to really limit is the amount of foods that we consume that do require preservatives, right? It's okay to have a little bit of foods that contain preservatives in them. You just don't want to make that your principal diet source. All right.